security, we have what are called security groups and network access control lists. These are what are comparable to the firewalls that protect some very key areas in our virtual private cloud. We also have AWS IAM, what stands for AWS, Identity Access Management. This is how we secure our services within AWS. We move down to that next technology of networking. A little compare and contrast again. We have routers, kind of the brains of the operation that tell our data where it's going to send packets of information to and from. A network pipeline. We have switches that are enabled with it as well. And over on the AWS side, you heard me mention something called a VPC previously. So a virtual private cloud allows you to carve out your own little unique world within AWS to deploy your services. In addition to our virtual private cloud, we also have something called an elastic load balancer. So when we start to deploy those resources, which we're going to talk about in just a little bit, also known as EC2 instances, the Elastic Compute Cloud, we may have the necessity that says, hey, every once in a while I get these network spikes and I need to be able to have my instances expand and contract on demand. Well, when that happens, we need to use the service called an elastic load balancer. An elastic load balancer will allow us to deliver that traffic to healthy instances inside of our VPC. So all of these services together through security and networking so far, you can see there's a nice mix of services that are very comparable, very, very cost-effective to stand up in the cloud. With our servers, again, no more maintaining physical box on-premise servers. We have something called an Amazon Machine Image, also known as an AMI. An AMI is a template that we use to launch our Elastic Compute Cloud instances, also known as EC2. That template provides for us the means to stand up identical instances every single time we use that template. You can pick your operating system, you can load your applications onto it. Essentially, it gives you the ability to stand those instances up in a mere few minutes. With storage and database on the bottom, we have our directly attached storage, our storage area network, our network attached storage, and our relational database management system. I think that covers all the acronyms to the left. On the right, from the AWS cloud side, we have Amazon Elastic Block Storage. This is what we know as persistent storage that gets attached to our EC2 instances. And again, more on this as we move forward with the content. We also have an Elastic File Service. So if you've ever mapped a drive to be able to share files within your organization, this particular service, Elastic File Service, also known as Amazon EFS, allows you to accommodate that. And last but not least, with our storage, we have our Amazon S3, our simple storage service. Our simple storage service allows us to store objects. Now, I mean objects of all shapes and sizes. I shouldn't say all sizes. A maximum for each one of those objects can be up to 5 terabytes in size. That's pretty big, so it makes a really, really good spot for storing database backups. Last but not least, we have our Amazon RDS. This is our relational database service, and we have a variety of platforms to choose from. So all in all, these are your 5 services that we're going to delve a little bit deeper into them as we continue through the rest of the session. Some of those key service areas that I just mentioned, you might say, hey, Michaelin, you mentioned all of these key service areas, and you did the compare and contrast of the on-prem inside of the AWS cloud, but how does it all work together? So if you take a look, we mentioned before that you have your application, whatever that application may happen to be. And we mentioned a VPC. So you can see the virtual private cloud allows us to carve out that area of our own virtual private cloud inside of the AWS system. Inside of our virtual private cloud, we have the ability to launch an image with called an Amazon EC2 image. The EC2 becomes what you want to make it. So if you have requirements that say, I need a web server, then we just simply create the EC2 instance to become a web server and maybe load Apache onto it. If your boss comes to you and says, well, hey, Michaelin, I need you to create a web server, an application server, and a database server. It's as simple as saying, great, I'm going to launch these EC2 instances, but I'm going to load different software onto each of them so that they become what I need them to become. One is a web server, one is an application server, one is a database server, all while being able to have persistent storage called the Amazon Elastic Block Storage or Amazon EBS. Over to the left, you see that we have a user, and you see looks like a route sign. It says 53. This is what we call Amazon Route 53. This is our domain name service, also known as a DNS. So as a user, when we go out to the browser of our choice and we type in a web address, the Route 53 DNS is going to resolve that address that we type in because as humans, we like English like text, but computers tend to like numbers a little bit more. So Amazon Route 53 is going to take that English like text and convert it into an IP address, which enables us to go ahead and send that network traffic into our EC2 instance, which most likely is going to house our application on it. Now, the other services that you're looking at outside of the VPC, such as Amazon S3, AWS Lambda, Amazon SageMaker, and Amazon DynamoDB, you might be thinking, those are outside of that little box called the VPC right now. So what do those services do? These services in particular are what we classify as serverless. And yes, there are still servers, but we'll get to that in a moment. This, not to mention that they're serverless, but we also have Amazon SageMaker, which is machine learning. So all of these, the Amazon S3 can provide additional storage for our objects that may interact or integrate with our Amazon EC2 instance. Lambda, the things we can do with Lambda. We're going to get to that here in just a moment. But as long as you can supply the code, Amazon Lambda actually functions in millisecond timing. So with Lambda, we can trigger any type of function to run, maybe to take data from our S3 bucket, maybe load that into SageMaker. Our Amazon DynamoDB has millisecond timing as well. So depending upon, maybe we're storing a customer application there and we want to do a little bit of machine learning based upon how the customer interacts with our database, all of these services together have the ability to integrate with one another. Before we go on, just a couple of cloud terms that we have here. Now, I won't go through every single bullet point, just be aware that they do exist, but some of the ones that bear a little bit more importance as we walk through this class, I'm going to start in the upper left with auto-scaling. Auto-scaling allows our system that we build within the cloud to scale to the capacity of the traffic that we have coming in. So if on one particular day we have an overabundance of traffic because maybe we released a new game, or maybe we're having a sale from a retail application, maybe we've just had some type of an upgrade to our system with new capabilities associated with it. So we have an overabundance of traffic. Auto-scaling allows us to scale out so that that traffic, none of it's going to be dropped, and all of our customers are going to get serviced in the fashion that they are accustomed to. Big data, well, it's kind of what the name says it is. Big data is nothing more than a very large volume of data that can come in structured, semi-structured, or unstructured. But why do we need big data? Because maybe there's something in that data that we can learn from. A lot of times we use big data to feed into machine learning, advanced analytics techniques, and they characterize this by using what are called the 4 V's. So if you've ever heard of those before, you're right along with me at this point. But if not, just so you know a little bit more about big data, it's the volume, as we mentioned, the variety, the veracity, basically the trustworthiness of the data, and the velocity. How fast is it coming in? We know what cloud computing is at this point. I just wanted to mention a couple of other items in here, such as elasticity. So remember, the elasticity is being able to expand and contract. I like to call it with grace. So none of that hair on fire moment that says, we don't have enough servers. That's not an issue. With the cloud, we incorporate elasticity as we build our infrastructure, so that way, when network traffic expands, we have elasticity in our system to get larger and smaller when that network traffic dies down. A couple more that you may or may not recognize in here. I had mentioned serverless and serverless computing. So with serverless and serverless computing, there are definitely servers behind the scenes. However, that's not something that you have to worry about. This is AWS's responsibility. Your only concern with this is telling AWS, this is the configuration I want, but this is how fast I want it to be. AWS behind the scenes will go ahead and build that infrastructure so that it will run as fast as you want it to run. With that, our first area is going to be compute. We are going to begin our journey with those 5 core services, starting with compute. AWS offers 3 types of compute at the fundamental level: virtual machines, container services, and you heard me mention serverless. So a little bit more on that as we go forward. So Amazon EC2, also known as the Elastic Compute Cloud, can solve a lot of problems that are more difficult than to be able to serve that with an on-prem server. Now, they do call them disposable resources, and that's because we can spin them up so fast within minutes. And if you decide, I just needed that as a proof of concept to show how an application might work, we can do that, because immediately we can also terminate that resource at any given moment. If in the on-prem world, we decided, hey, I'm going to ask my boss if I can order this server and configure it for a proof of concept. I don't know about you, but my boss was never that forgiving when I worked in the client server world. So there really wasn't a thing called a disposable resource at that point. This is the benefit that Amazon EC2 gives you to solve some of those on-prem server issues. Plus, you're not maintaining the backend. We want to turn our thoughts to making data-driven decisions, being able to quickly iterate what we want to do next with that data that we've just decided to say, yeah, we need a couple more instances. And if we do make a mistake, over-provisioning, under-provisioning, we can fix it really, really fast. So free to make mistakes, you have a little wiggle room there, a little bit more than what you had with on-prem. With the cloud itself, this is your resizable compute capacity, and you have complete control of your computing resources, meaning you can pick from an overabundance of instance types with different memory and compute for basically just about what any requirement you may come across with the type of server that you need to create. We can reduce the time required to obtain and boot new server instances, and the reason why that is because we use what are called Amazon machine images. Those are the templates that we can start with to begin to create our Amazon EC2 instances, just like a cookie cutter. Some of the benefits of EC2 is, well, we have elasticity built into it. I told you would hear that word again. You have complete control over those instances. You can start it, you can stop it, you can terminate it, you can reboot it. You can even put it into hibernation mode if you're not using it all the time. You have the flexibility to choose whatever type of instance that you want, and it is integrated integrated with a number of other services within AWS. So we see our VPC, we talked a little bit about auto scaling, we have an elastic load balancer there. They're reliable, 99.9% availability. They're secure because we can put virtual firewalls and security at all layers around our VPC and our EC2 instances. They're pretty inexpensive. So depending upon the region that you select, you're going to have a little price point there. And I'll tell you, the last time I spun up an EC2 instance, although it was pretty small, 1 virtual CPU, 1 gig of RAM, I think, the big spender that I am, I think I paid a whole $0.015 per hour. And I'm not joking about that. That's what we mean by inexpensive. Now, don't get me wrong, there are some other instances out there that are going to provide you a lot more compute, a lot more memory, and a lot more oomph behind the scenes. But initially, you can pick what your price point is. And of course, it's simple. It's going to send you on a guided path with areas that you're going to pick to configure that EC2 instance and eventually launch it. With Amazon EC2, it is a pay-as-you-go pricing. So whether that's pay by the minute, pay by the hour, depending upon the instance type that you have selected. We also have availability called the AWS Marketplace. And this is another area where you can pick out an Amazon machine image. So if you said, well, maybe I want an AMI that already has a service like Barracuda loaded on it. I can go out to the AWS Marketplace through an approved vendor, and I can select that AMI that already has everything loaded for me. That's an option, of course. The template for creating those EC2s I had mentioned was an AMI, Amazon Machine Image. This is going to give you a set of storage volumes to start with, launch permissions for the region of choice so that you have security to launch your instance inside of that region, and what we call a block device mapping. Some of the examples that you're showing here and what I had mentioned before is your EC2 instance becomes what you need it to become. So whether it's an application server, a web server, database server, and a few more that you see here, those are all of your options. It's what your requirements are asking you to load onto that EC2 instance. As far as pricing goes, there are 4 different options. So one on the left says on-demand instances. Depending upon what your use of those EC2 instances is going to be, you'll most likely end up picking one of these choices. Now, if you said, I just need an instance to work for the next 24 hours, but I don't really need it after that, most likely you're not going to enter into a commitment with AWS that's going to be over a period of time. You more or less want kind of one of those disposable instances. And that pricing point is going to exist in what we call on-demand instances. You pay for the time that you use it, and when you're done, you terminate it, and you're good to go. If you said, well, hey, Michaelin, I'm going to need 15 instances, and I need them for the next year. Can I get a discount for that or some type of cost savings? The answer is yes. So if in fact you would like to enter into a commitment to utilize and take advantage of cost savings with AWS, there are 2 choices. We have what are called reserved instances, and we have savings plans. So reserved instance is built on a commitment of 1 or 3 years, I did say 1 or 3 years, to utilize an instance at a specific price over a specific term. The second option is a savings plan. This is built on the commitments of spend, so a specified dollar amount per hour over a defined period, 1 or 3 years. So if in fact you know that your long-term commitment is going to be 1 or 3 years, you probably want to take advantage of that cost savings. It's somewhere in the ballpark of about 72% of a discount from what you would pay for on-demand instances. So you'll see that with the pricing from our AWS console. You might say, well, Michaelin, you left out one last item in here called a spot instance. So what is that? Well, I saved the best one for last. Now, with the Spot instance, you have the ability to save up to 90% off of the on-demand instance. Now, if you think back just a little bit ago, didn't I say it was like a penny or a penny and a half per hour? 90% off, 0.3 of a cent, really? So the answer is yes. You might say there's gotta be a catch with the Spot instance. So not necessarily a catch, but AWS in those 31 current global regions that we have right now where you pick where you want to launch your resources at, we have data centers running 24/7, just waiting and making sure that we can accommodate all of your needs. So in some of those data centers, we have some unused capacity that's waiting for somebody to spin up some type of a resource with AWS. So in having some of that, we also have some unused capacity, and AWS is willing to sell that at a discounted price, of which we call a Spot instance. Now, you might think, oh wait, here it comes. So there is a little caveat to that. If, in fact, that Spot instance is going to now be recalled because there is another person who needs capacity for their servers, that Spot instance will be recalled within a few moments' notice, basically 2 minutes. You might say 2 whole minutes? I guess this is really not a good selection for a production environment. No, it's not, but every single AWS service has its place. So on demand is for quick up and down of those services that maybe you don't want to take the chance that the resource might get recalled for its capacity. But if you said, hey, you know what, this is running a batch load, and if it gets stopped and started because the Spot instance gets recalled, I'm okay with it. So therefore, that's a great use of what we call Spot instances. So just know going into it, the capacity might be recalled. But these are your 4 options. So on demand, reserved instances, savings plans, and Spot instances. With our EC2 instance families. Now, when you go to configure your Elastic Compute Cloud instance, we have these 5 different classifications of services for our instance family. One is general purpose, and it's a pretty good balance of compute, memory, small to mid-sized databases. We have compute for high-performance web servers, video recording, memory optimized, storage optimized, or accelerated computing, something that we might want to use for machine learning. So all of these are your different choices and flexibility or agility to stand up your EC2 instances as you go through the process of launching that resource. When we have been talking about our EC2 instance, there is unmanaged services compared to what we call managed services. So I spent a little bit of time talking about EC2 and AWS, which you will hear me mention through the rest of our session today. We'll talk about managed services and an unmanaged service. So far we've talked about EC2, which is technically classified as unmanaged because we as a customer take the responsibility of the majority of what we need to do with that instance. We need to patch it, we need to fix it, we need to update it, we manage the scaling of it, the fault tolerance, and the availability of it. AWS is taking care of the infrastructure behind the scenes. But some of our other AWS services, which you're going to hear shortly, are managed services. And a managed service means that AWS already built in scaling and fault tolerance and security to these services. So more on that as we continue through our service. Amazon Elastic Container Service. So you might be saying, oh yes, this was the second one of those compute options we talked about a little bit before. This is called a container service, and some of you might be familiar with what we call a Docker engine. So a container itself is really a packaging mechanism, self-contained environments that are basically faster to spin up and down than virtual machines, like the EC2 instances I just mentioned. They're very portable. They're extremely scalable. It's a standardized unit of measure that can package your application code and any of its dependencies in one area called a container. It can run on any operating system. Applications can run the same on any machine without compatibility issues, with predictable behavior, and with more efficient maintenance and deployments. So the service that we use inside of Amazon to run our containers is called Amazon ECS. This is our Elastic Container Service. Because containers are small in nature, when we start launching a lot of them, the issue becomes with the orchestration process. So maybe we have 5 containers running on one EC2 instance here, and another 4 over here, another 5 over here, another 8 over here. And you might say, I don't know which container went where. Well, this is what ECS does for us. Elastic Container Service takes over the orchestration of when I launch this next container, where should I put it? Where is the recommended space availability for what I need for this particular container? It maintains and scales a fleet of those nodes for you, running all of your containers, and it removes the complexity of standing up an infrastructure for it. What is serverless computing? So we're a third option. So maybe your manager comes to you and says, hey, Michael-Lynn, we have all of these EC2 instances running 24/7. We're looking for a way to trim our budget a little bit. Is there a way we could be a bit more cost effective? Enter serverless computing. Serverless computing is you pay for it while you are using it. And if you're not using it, the service is idle. If the service is idle, we don't have a charge for it. Serverless means there are no servers for us as a customer to provision or manage. We simply configure the service and ask AWS to build the servers behind the scenes so that it will scale with when we use it and scale in when we don't need to use it any longer. It has availability, it has fault tolerance, everything that you need built into these services. And you probably guessed it, yes, serverless computing are managed services within AWS. Some of the serverless application uses that we have, we can use our web applications for static websites. We have backends for different applications and services that you want to run, mobile, Internet of Things, also known as IoT, data processing. You have chatbots, logic running behind the scenes. If you have machine learning, Amazon Alexa is also a candidate for serverless applications as well. I'm sure some of you have used some of the Alexa technology there. And IT automation. So policy engines, auto remediation, extending our AWS services, and essentially infrastructure management. We have services that can build for you infrastructure as code in an automated service. Lambda is another serverless service. Now you heard me mention this when we initially started to talk about all of the different services working together. And I said, oh wow, the things that you can do with Lambda. It is a fully managed compute service. It runs stateless code. And you might say, well, what kind of code does it support? Is it something I might know? So whether you want to use Java, Go, PowerShell, Node.js, C#, Python, or Ruby, just to mention a few, those are some of your options. It can run your code on a schedule. So if you said every Friday morning at 8 a.m., this is what I want you to do. Or if you said, well, what if I want it to run when it's triggered? Well, what do you want that trigger to be? The example we see here is, what if a file gets placed into an Amazon Simple Storage Service bucket, also known as S3, and as soon as there's data or a file detected in that bucket, I want AWS Lambda to fire. And when AWS Lambda fires, it's going to go get that file for me out of that S3 bucket, and it's going to take it to another service. And let's even say it's Amazon DynamoDB. So for there, the AWS Lambda starts up, which you begin to get charged for. It grabs the file, it deposits it into the DynamoDB table, and the AWS Lambda serverless, fully managed service shuts back down. You only pay for what you use, and only while it is in progress of doing whatever that function may happen to be. Well, it is that time. We have a little knowledge check here. So to make sure that I'm explaining everything properly, I'm going to give you just a moment to take a look at the question and all the answers that we have. So for here, it says, which of the following is not a feature of Amazon EC2? So I'll read that one more time. Which of the following is not a feature of Amazon EC2? So you can even pause your screen if you want to take a moment just to read down through all of those letters that you see here. And as we start to take a look, we can see in here, remember what EC2, Elastic Compute Cloud, does for us. So A, broad selection of instance types for different workloads. That seems like that's something that EC2 does, right? C, multiple pricing options per second billing or per hour billing. We talked a little bit about that as well. Complete control over the instance and remote access options. Also talked about that. Reusable templates for launching additional instances known as Amazon Machine Images. That also looks like a really good answer. But there's one in there that gives me a little bit of pause. So we talked about what is a managed service compared to an unmanaged service. And EC2 is in fact that unmanaged service. So B is the correct answer, which is not a feature of Amazon EC2. Fully managed compute service that belongs to Lambda. Last but not least, just a few things to give you a summary of what we just talked about for compute. We have our EC2 instances, our Elastic Compute Cloud, which is our servers in the cloud. Pay-as-you-go pricing. You can elastically scale out or in as needed automatically. You get to pick from the instance types that you want for your workload. We have the Elastic Container Service that allows us to orchestrate the deployment of those containers for your applications. And we saw some serverless. We can create the code. AWS manages the underlying compute for us. We only pay for what we use or while we are using it. And we also took a brief look at Lambda, which is our on-demand per request pricing to run code. We next have storage. Storage is a very important part in AWS. And I will tell you, as we have new customers that come on board with the cloud every single day, storage is honestly one of those first places that people choose to dip their toe into the water. And you might say, well, Michael Lynn, why is that? Well, storage is a serverless service. And with Amazon S3, it is very scalable. It's basically infinite. So the more data you put in, the larger it's going to grow. However, remember, you need to pay for that storage. So upload as much as you like. It's going to expand and contract as you put more data in or take more data out, those objects. We also have a few additional services. S3 Glacier, which I'll explain in a bit more detail in just a moment. Elastic File Service. So this is truly a network file storage option for you. We have the AWS Storage Gateway, which is if you still have some services running on-prem, and you also started to deploy your services in the cloud, this is what we call a hybrid cloud approach, meaning you're running a little bit of both. And you might say, well, I have this data that's on-prem, and I'd really like to make sure I have the security of backing that up in the cloud. We can use a service called AWS Storage Gateway. We also have our elastic block storage. This is our network attached volumes that typically we attach with our EC2 instances, our Elastic Compute Cloud. And to match the Amazon Elastic File Service, we have both a Windows and a Linux version of that. So EFS is going to be our Linux version, and our Windows version is going to be Amazon FSX. With our Amazon S3, we have a few different tiers of storage, and the difference between S3 and Glacier is S3 is your standard storage, and Glacier is going to be something more along the lines of archival. So if you have data and you don't use it very often, but you need to maybe retain it for a certain period of time, you can place that data into what we call S3 Glacier. And it has a much lower cost to it. With Amazon S3, you might be saying, all right, we've been talking about this off and on here for the last several slides, so what exactly can I do with this? So Amazon S3, unlike EBS, which is block storage, this is what we call object level storage. It's great for storing backups of your database, big data analytics, maybe a disaster recovery option. We even have some options with our S3 buckets, which is what you're looking at here. So they are stored in what are called buckets to host a static website. Object level storage will allow you to store any one object up to the size of 5 terabytes. Yes, you did hear me correctly, 5 terabytes. So if you have 15 objects and they're all individually 5 terabytes, put them all into Amazon S3. As long as you don't go over that object size, you're good to go. And anything underneath of it as well. It is designed for 11 nines of durability. 11 nines of durability, which means if you had 1 million files over the course of 10,000 years, you might lose one. That's not too bad for durability. It also allows you to turn on what are called event triggers. I just mentioned one about Lambda when data gets populated into an S3 bucket. So it has a number of event triggers to integrate with other AWS services. File services and some of their use cases. So I had mentioned before about, have you ever had to map a drive to be able to share files with someone? This is the cloud version. So we have our Elastic File Service, and some of the use cases for it, application development, sharing of files, management systems, possibly a little bit of data science. So this is our Linux version, Amazon EFS. Amazon FSX for Windows over on the right. This is going to be for our Windows file servers into AWS, making sure that we have storage for possibly our hybrid workloads in the cloud. We can reduce the Microsoft SQL Server development costs or deployment costs that we have, and simple virtual desktops and streaming are all included with Amazon FSX for Windows. FSX for Lustre, if you've ever used this before, this is for high performance computing, media workloads, data analytics, things such as that. So these are our few file services and some of the use cases that we can use them for. Amazon Elastic Block Storage. Now, I did mention this along the lines with our Elastic Compute Cloud instances. This is what we call persistent block storage. This is normally what we would load our application software onto for our EC2 instances to run. They are protected through replication. They can have different drive types. They can scale up or down in minutes. You only pay for what you provision. So if you need 8 gigs, you pay for 8 gigs. It also has a built-in lifecycle functionality for snapshots, so it allows you to take point-in-time snapshots of your volumes. And you might say, "Ooh, Michaelin, is this a good example of being able to take a backup and store it into S3? Yes, that's an excellent way of doing it. And you can also fully encrypt any of your Elastic Block storage volumes. A little knowledge check here about storage. Which of the following services offers object-based storage? So I'll read that one more time. Which of the following services offers object-based storage? So I'll give you just a moment to take a look through those answers, and then we'll go ahead and display which one is going to be comparable for that question. So probably going through some of the things that you just heard, the last one we looked at was Elastic Block Storage, which we know is persistent block storage. Didn't mention really the word object-based, so probably not going to be the answer for that. Storage gateway is our ability to have a hybrid approach where we want to take data from possibly our on-prem and transfer that into the cloud. So not really object-based storage either. Elastic file system. This might be one of those areas where the storage gateway is actually transporting that data to. So that's our Elastic file system. And Amazon Machine Image, well, that was kind of our template for building our EC2 instance. So what does that leave? That leaves our last one of the group, which is Amazon S3. Amazon S3 is truly what is called object-based.
Sí, tal cual, eso ya lo sabía yo. Muy bien.
A few parting comments for our storage area in here. AWS provides a variety of storage options for you. So we have our simple storage service, which is object-based. We have file-based, which includes Amazon EFS for Linux and Amazon FSx for Windows. And we also have block storage. That's our persistent storage that we want to attach those volumes to an EC2 instance. So customers are using our storage services to build home directories, data lakes, business critical applications, and so much more.
Database. Vamos. RDS, DynamoDB, S2 con base de datos. Esto lo sé.
We have our do-it-yourself unmanaged service, which we talked a little about. Our EC2 instance. So remember, EC2 becomes what you need it to become. We load the software if we want it to be a web server, application server, or database server. But we do know that we are the ones maintaining the majority of those services, which is why we call it an unmanaged service. We compare this to our database services, which are managed. We can log into the management console of the AWS. It's pretty simple to set up. You go through the configuration, you pick the instance type that you want. It's push button high availability, meaning you say, I might want to deploy it in multiple availability zones, so I have some failover, and it will deploy it in the availability zones within your region of choice. We are focusing on performance. So we're not worried about maintaining the back end of this. We're worried about how is this going to perform for my applications for my customers. And it does come with a managed infrastructure. Our databases, and you might think, wow, that is a lot of databases. Our databases are all purpose built. If you look along the left side of your screen, we have our relational databases. These are what are known as our predefined table structures. They have relationships between them, rows and columns.
Está bueno,
These are traditional applications like enterprise resource planning, customer relationship management, e-commerce, things like that. We have Amazon Aurora. We also have Amazon Redshift, which is going to be our data warehouse. And then as we start to travel to the right, we have our key value database known as Amazon DynamoDB, which more on that database is coming up as well. This is optimized for common access patterns. It retrieves large volumes of data. It has a millisecond timing. high traffic website applications. It's really great for gaming applications or e-commerce systems, such as those we might know of that might have a shopping cart. So we put things in, we take things out, we buy them, they get shipped, everything's great. We also have in-memory databases with Elasticache and our Amazon MemoryDB for Redis. These are used for applications that are going to require real-time access to data, caching, session management, gaming leaderboards. We know how fast those change. We also have our document database, which is designed to store semi-structured data, such as JSON-like documents, and they're used for content management, catalogs, and user profiles. We next come to our wide column database. This is another of our NoSQL database. They're used for high-scale industrial applications, equipment maintenance. Think of fleet management or route optimization. So Neptune databases are great for applications that query millions of relationships. So think of social networking applications that you have been on. Also, this is a really good one for fraud detection and recommendation engines. So what are we going to buy next, right? Ledger databases, these are provided for a central trusted authority to maintain scalability, immutable and cryptographically verifiable record of transactions. We'll talk a little bit more about ledger databases in just a bit. And then we also have time series. So think about queries spanning over a period of time or time intervals, and they're used for Internet of Things types of applications, sometimes DevOps or development operations, and then industrial telemetry data. But more of our focus will come back to our relational database service. So this is a managed web service that helps our customers create and manage high scalability, secure relational databases in our AWS cloud. Customers are not responsible for hardware provisioning, which makes this a really sweet deal. Database setup, software patching, and backups, again, not your responsibility. AWS manages the common database administration tasks. It also supports the usual suspects that you're looking here on the screens, including the commercially available Oracle and Microsoft SQL Server, our open source MySQL and PostgreSQL, as well as MariaDB. Amazon Aurora, Amazon RDS, we store and transmit our data securely. A little bit more on Amazon Aurora as we go forward. With Amazon Aurora, this is one of the options which is compatible with MySQL and PostgreSQL. So Amazon Aurora is a fully managed relational database engine. You can pick which compatibility option you like as you build the RDS, Relational Database Service. You already know how MySQL and PostgreSQL combine the speed and reliability of your high-end commercial databases with simplicity and cost-effectiveness because they're open source. The code, the tools, the applications that you use today with MySQL and Postgres can also be used with Aurora. With some workloads, Aurora can deliver up to 5 times the throughput of MySQL and 3 times the throughput of PostgreSQL without requiring changes to the most of your existing application. It also has high performance storage subsystems. It's MySQL and PostgreSQL compatible. It's customized to take advantage of fast distributed storage. With Amazon DynamoDB, so yet another one of the popular choices, which is also known as a NoSQL database, service for any type of scalable, highly scalable application. Fully managed NoSQL database that gives you fast millisecond predictable performance with seamless scalability. It is also known as what we call a key value database. So since it's serverless, no provisioning, no patching, no installing, no managing software applications and servers, and it does offer encryption at rest for protecting your sensitive data. All of your data is stored on SSD, so solid state disks, It has automatically replicated across multiple availability zones, so high availability is already built into it within an AWS region, and it gives you built-in high availability and data durability. So you can use what are called global tables to keep your DynamoDB tables in sync, not just across one region, but across 3 different regions. This is going to wrap up our database area of our session with a knowledge check. So which of the following services can be used to deploy NoSQL workloads?
DynamoDB.
So as you're looking down through that list, this one's got a little bit of a shorter option to choose from. So again, which of the following services can be used to deploy NoSQL workloads? Well, we know that relational databases, it's really kind of what they were built for is SQL. So Amazon Aurora was one of those options. Amazon RDS was another. And Amazon Redshift briefly mentioned this is for a data warehouse, but also it is meant for really SQL. So our only option that you see here is our NoSQL database, which is what we wrapped up our conversation on, Amazon DynamoDB. A few things that you can take away as a summarization of our section on databases. We have our relational options, so Amazon Aurora, Amazon RDS, and Amazon Redshift. We have our non-relational databases, such as DynamoDB, Neptune, which is our graphing database, our document database, Amazon Keyspaces, Elasticache, and our Quantum Ledger database, also known as QLDB. And we also have an option for TimeStream. Just remember that NoSQL databases are widely recognized for their ease of development, functionality, and very, very fast performance. A little on networking. So we've talked about compute, we've talked about storage, we have talked about databases, and a lot of these things can be deployed throughout our VPC network. And we also talked a little bit about serverless options as well. So I like to think of the networking piece of this as the superhighway of packet delivery. So with our Amazon Virtual Private Cloud, also known as our Amazon VPC, this is your option to launch your AWS resources in an logically isolated virtual network that you get to define. One of AWS's foundational services, the VPC, makes it really easy for you to customize your networking configuration. You can create a public-facing subnet for your web services. You can create a private subnet for services that you really don't wish to have direct access for your internet. So a little bit of networking isolation for your workloads. I talked about public subnets, which are going to give you that direct accessibility from your public internet through the internet gateway. So perhaps we deploy maybe our EC2 web servers there. But in the back end, we have our private subnet. So this might be where certain types of data that, well, I don't really want it to have direct access to the internet. That's data that we prefer to keep private, such as our application servers or our database tiers back here. Last but not least, we want to balance all of that traffic out to healthy instances that we have running inside of our VPC. And the way that we do that is through the use of what we call an elastic load balancer. So this is going to distribute that incoming traffic and network traffic to available instances for processing. Now, security, and more security in this ever-changing world is always something that we want to keep in mind. So with a VPC, and one of the things that AWS will not only say once, twice, or 3 times, but continually through many of the different discussions, not only today, but I'm sure things you will hear in the future, layers of security. Security at all layers, including firewalls that we can set up individually inside of our VPC. So the first firewall is called a security group, and a security group is meant to allow traffic to and from what is called our EC2 at the instance level. Usually administered by your application developers, whoever is setting up your EC2 instances. And then we have a subnet, so our EC2 instance is deployed inside of a subnet, and that subnet allows us to have what are called network access control lists, so network ACLs if we're using an acronym. And this will have rules that allow or deny specific sets of traffic in and out of our subnets. So this allows us to harden our security a little bit as a second layer of defense at our subnet level. And last but not least, I like to call the route table the brains of the operation. So what our route table is going to do for our distribution of that traffic is it's going to have what are called a set of rules that are called routes. And those routes are used to determine where that network traffic is being directed to. So route tables can have an association with VPC gateways and our subnets. So this, in conjunction with the sets of rules, the network ACLs at our subnet level, and our security groups, which only allow certain traffic to come in and interact with our EC2 instance. Now you might say, okay, we've looked at all these different resources and VPCs and a little bit of security because there's more of that to come, but how do I get there? So how am I going to connect with the infrastructure that I see in front of me? Well, you have a few different ways to do that. We have our open VPN client. So our AWS VPN endpoint is what you're going to utilize to get access into your VPC and your resources. That's one way. We also have our site-to-site VPN, which would just require us at our on-prem data center to have a customer gateway set up so that it allows interactions between our on-prem data center. And then on the VPC side, we're going to have what is called a virtual private gateway, so that it only allows traffic from that corporate data center to interact with the resources inside of our VPC. And one last option here, this is called Direct Connect. So with Direct Connect, this is a specified concurrent bandwidth, which you get to select. So the other two options above, like OpenVPN client and our site-to-site VPN, just remember that even though they are secure, you are still at the mercy of the speed of the general internet. Whereas with Direct Connect, you get to pick your bandwidth. And this is a dedicated bandwidth that you get to set up through the use of this service. So those are your three ways of connecting into your infrastructure. A little knowledge check here. Which of the following are layers of network defense for VPCs? Oh, but wait. This one you get to choose three. So which of the following are layers of network defense for VPCs? Pick three.
Bueno, obviamente BCD me parece, ¿no? Las tablas de routeo no tienen nada que ver y la SAMI, no. No, yo creo que no. Bueno, veamos.
All right. So, in looking at our answers, our very first one up there is our Amazon machine image. You might say, well, yeah, Michael, and you told me that was for building EC2 instances, so I immediately knew that wasn't it. And we just talked about network access control lists that control the firewall at the subnet level, and security groups, which allow certain amounts of traffic or certain traffic into our EC2 at the instance level. And the brains of the operation are VPC route tables. And you might say, yeah, that S3 lifecycle things, I don't even think we've talked about that yet. And you are absolutely correct. We're going to get there here in just a moment. So your three correct answers for which of the following layers of the network defense are layers of network defense for VPCs are your network access control lists, your security groups, and your VPC route tables. Last but not least, just a little summarization of what we talked about with networking. So what does a VPC allow us to do? It allows us to create our own isolated network to launch our applications. It provides us with a couple of layers of security that including security groups, network access control lists, and route tables to secure deployments. And there are three main ways that we can connect to AWS: a client VPN, site-to-site VPN, and then a dedicated bandwidth in which we can use the service of Direct Connect. The last and final of our 5 core foundational services that we're going to wrap up section 1 of our awesome day today is security. I had mentioned before that this is probably one of the most important areas. We always want security at all layers. Remember what happens. We don't want to be that person that ends up on that nightly news platform because somehow someone else from the outside was able to access our data. So security is our top priority here at AWS as well, and we feel that way about all of our customers. We have gained control and confidence you need to securely run your organization with most flexible, secure cloud computing environment available today. Improve your ability to meet core security and compliance requirements, such as data locality, protection, confidentiality, with comprehensive services and features that AWS offers. Things that we want to protect most: identity and access management. This is being able to provide and manage the access to our workloads and our applications. Detection, so continuously being able to monitor and make sure that there's no malicious activity or weird account behavior going on behind the scenes. And then we also have our network and application protection. So we want to enforce that fine-grained security policy at every network control point. Highly automated, highly available, and highly accredited with many, many organizations. With AWS, we have what is called the shared responsibility model. So security is everyone's responsibility, but when it comes to security of the cloud and security in the cloud, there's a slight division of responsibility. So on top, we see customer responsibility. This is your customer data, the platforms, the applications, the identity and access management, so who you're letting into your resources, the operating system, network, firewall configuration, so what have you set up for those layers of security to enact with your infrastructure, client-side data encryption, server-side encryption, network traffic, so security groups, and our network access control list, protecting encryption with integrity and identity. And then you might say, wow, that's a lot. So what does AWS do for us? Well, this is our responsibility for security of the cloud. So our responsibility is to ensure all of those foundational services that when you deploy them, the compute, the storage, the databases, the networking, those services are all up, running, and available and dependable for you. The global infrastructure, the regions, each one of those regions and their many availability zones and edge locations around the world that we want to deploy our applications to and cache that available data, so we're bringing it closer to our end users for lowest latency possible. That's AWS's responsibility. Identity and access management is what allows us to give that fine-grained access to our AWS resources. So one of the principles that we live by here at AWS is the principle of least privilege, which means if you don't need to give someone access to it, don't. It's not a default action in AWS. As a matter of fact, when you initially set up your account, no one has access to anything. No services can talk to one another. No users can do anything until you explicitly provide them security to it. So this is your area within AWS, the Identity and Access Management, also known as IAM. This is where we grant our granular permissions to users, groups, and what we call roles.
Bien.
We can share temporary access to our AWS account if we want, and we can also federate users into our corporate network with an identity provider. Some of the components of identity and access management are our users. This is a person or an application that interacts with AWS. We also have a way of maintaining one-to-many users that might require identical permissions. These are called groups. And last but not least, we also have IAM roles. IAM role is temporary access to those AWS resources. And you might say, well, why would I use a role versus just creating a user? We don't really wish to make any more maintenance than what's necessary. And sometimes we have users that need to come into our system, but it is for a temporary period of time. Perhaps an auditor that's here to look at your data, or perhaps a consultant that's here to maybe merely do a couple little adjustments to something that you've been working on with one of your resources. So we don't want to give them full access all the time. We want to give them temporary privileges by which we are complying with the principle of least privilege. Now you might say, so there's permissions and policies down there on the bottom, so what are those? So permissions are, what are we giving you access to? Is it the ability to create a simple storage service bucket? Is it the ability to start an EC2 instance or stop an EC2 instance? And the way that we package those permissions is in a JSON policy. So a policy can contain one-to-many permissions at which we can attach those permissions to users, groups, and roles. All of this can be done through identity and access management. Now, back to that principle of least privilege. Default is no access except for the owner, in this case, of the S3 bucket. So Amazon S3 access control in general, when you go in and create a simple storage service bucket, so that is essentially where we will put all of our objects at, by default, only the owner has access to any of the objects in the bucket. So if you want to change that access, you must explicitly grant it. All right, so principle of least privilege. So if you said, well, I'm going to make this a static website. So since it's a web server, I want to let everybody in. So that is your choice, and you have the option to make your bucket completely public. Now, if you said, well, I'm not exactly going to make that a website, but I do need certain users to access it, but others not so much. So with this, we can create something called an access policy, or what we call a bucket policy, which enables us to control that fine-grained access to whom has access to the data or objects in our buckets. In addition to security, you might want to know who's in our AWS accounts. So AWS CloudTrail, I like to call this the monitor, or the auditor, perhaps. The AWS CloudTrail service is going to track all user activity and API usage in your AWS account. And believe me, it creates a trail. Who was it? When did they access? What did they access? Where were they in the service at that time? And it is a continuous monitor which produces records of all of those API calls. Every time you click to a new service, it checks to make sure that you have access to it, and it records that API of you going into that service. It's really useful for compliance and auditing. It allows that auditor who might come in and say, oh yeah, we've been doing a little bit of security analysis, and looks like CloudTrail is tracking all of the correct APIs of those individuals coming in and out of the services that you allow them to come in and out of. CloudTrail also produces log files and can deliver those objects, also log files, to S3 buckets. One last service, which is Trusted Advisor. So this is a service that is provided to you for everybody who has an AWS account. And you can see it's very visual. So there's a trusted advisor that tries to provide you recommendations for maybe cost optimization. We can see here that cost optimization underneath says potential monthly savings of $7,000 plus. So if somebody told me they were going to save me $7,000 of monthly savings, I might listen in a little bit more. If it was even $50, I might listen in a little bit more. We also have predictors of performance. So are we over provisioned? Are we under provisioned? Or are we just right? Security. Have you rotated your keys lately? So these are some of the recommendations. It might say, hey, it's been so many days since permissions have been rotated or access keys have been rotated. So this might be a recommendation that you want to take into consideration. Fault tolerance, so what do you have built into your services, or how can we help you improve them? And then you also have service limits. Now, no one needs to get excited about service limits. You might say, oh, does this mean I've overreached my service limit? Well, when you first start an AWS account, each one of the services has a soft limit for what you can create. So for example, we have a soft limit of 100 S3 buckets. And you might say, wow, that's a lot of buckets. Well, for some organizations, yes, and for others, maybe not. So if you hit one of those soft limits or get very close to it, this is what service limits is there for. So it's there to tell you, hey, you're getting close to that service limit, you might want to ask for an increase. So remember, I did say it was a soft limit. So you can go into support and just say, I need a service limit increase of this particular resource that I want to create. So this is what AWS Trusted Advisor can do for you. And it's very visual and it's very helpful through most of your services. We have a little knowledge check. So which of the following are components of identity access management? Which of the following are components of identity access management? Notice this time it didn't say how many it wanted you to select. So we're going to take a look and go through each of these items. So when we initially started talking about it, there were, users. So the person that can interact with the service. So that's a definite. We also talked about, well, if I have more than one person that needs the same permissions, I can put those into a group, right? Yes. So not only users, so C and A. And then if we look at a couple of other ones, B, buckets, not really components of IAM, right? That's a bucket is used to store objects. So definitely not B. When we look at D, which is an instance, this is a copy of an AMI, so EC2, not really anything to do with IAM. And last but not least, with E, this is your policy. So these are the policies that we write with our permissions intact to say what we are explicitly providing access to or maybe denying. When we look at our answers, it looks as if A, C, and E are correct. So this will give us a few more takeaways for our security. So security is everyone's responsibility, even though we devise it in a way so it's security in the cloud and security of the cloud. Identity and access management gives us the control to access our AWS resources by applying policies to users, groups, and roles. When an S3 bucket is created, by default, it is set to private, so only the owner of that bucket will have access. We learned a little bit more about CloudTrail and how it's our auditor. It tracks those API calls inside of our AWS accounts. So who did what, when, and where. And we also have Trusted Advisor, which is providing us recommendations along the way through multiples of our services out there about, do you have something over provisioned, under provisioned? Is it just right with performance? Can we improve security? Can we reduce some costs that we have? So all of those recommendations give us
está bueno.
well-ordered machine.
Está bueno, me gusta. Gracias. Muy bien.